multiple linear regression analysis and how it is applied in the business context. Let us also give you some examples. So before that, let us understand what is multiple linear regression analysis is all about. So it is a multivariate technique, is one of the multivariate technique, we all know that. So multiple regression analysis is a statistical method for estimating the relationship between dependent variable and two or more independent variables. We have simple regression analysis and also multiple regression analysis is available. You can see the formula here. It is y is equal to a plus b1 x1 b2 x2. It is the coefficient value of each variables we are trying to predict. Using these variables, we are trying to predict the predictor variable. So this is called a dependent variable, and this one, and this one is called a three independent variable. And it goes on how many variables we have. We have to write this regression equation. So this is the regression equation. Okay. So these variables are called predictor variables, and this one a is constant and y is called dependent variable. Are you clear about it? These are independent variables. So moving further, multiple linear regression. So simply, multiple linear regression is a method for studying the relationship between a dependent variable and two or more independent variables. So the purpose we talk about is one is for the purpose of predicting things, and the other one is for explanation. The other one is for theory building. Okay, that's why we use multiple regression analysis. And I will give you a context in business. For example, when you want to really evaluate, the employee motivation level. So the motivation of the employee become a dependent variable, and the other independent variables are like reward system, non-monetary rewards, workers relationship, working environment, like that. There are many independent variables which really trying to predict the motivation, overall motivation of the employee. Here in this context of this example, the overall motivation of the employee becomes the dependent variable, and the independent variable, just now I was mentioning about the salary, I mean the monetary reward, and the other non-monetary reward like transportation, children education, other perks. All this comes under other independent variable. And also the workers and manager and boss relationship and the working environment, all these become an independent variable which is trying to predict the dependent variable using multiple linear regression analysis. By looking at the coefficient value of each variable, we can predict how much of this variance is being using this coefficient value, we can predict how much this particular independent variable is trying to estimate the dependent variable, what you called in this situation as overall motivation level of the employee. So that's where multiple linear regression analysis is giving you a prediction, and also it gives you an explanation how much and on which variable as a manager has to give due importance so that it will really motivates the individual employee. And also it gives you a theory building that these are the variables which constitute the holistic model for motivation in an organization. So thus multiple linear regression analysis helps the researcher for the purpose of theory building also. So let us move further to elaborate on multiple linear regression analysis. Here in the operation aspects of multiple regression analysis, there are uses the ordinary least square solution as dash simple linear or bivariable regressions, which describes a line for which the sum of square differences between the predicted and the actual values of the dependent variable are at a minimum, and also it represents the functions that minimize the sum of the squared errors. For example, if you look at here, y is the predicted dependent variable and the other one is the constant variable, and these are the variables which is called the independent variable. These independent variables are helping us to predict the constant variable, the dependent variable called y. So next one is this multiple linear regression produces a model that identifies the best weighted combination of independent variable to predict the dependent, otherwise we call it as criterion variable. So basically here multiple linear regression analysis estimate the relative importance of several hypothesis predictors, and multiple linear regression analysis assess the contribution of the combined variables to change the dependent variable. So next one is like the design requirement of multiple linear regression analysis. So it should have certainly one dependent variable, otherwise we call it as criterion variable, and it should also have two or more independent variables, otherwise we call it as predictor or explanatory variable. And multiple linear regression analysis should have a large sample size, more than 50 samples, at least 10 times as many cases as independent variable. These are the criteria, the design requirement of multiple linear regression analysis. So the basic assumption of multiple linear regression analysis is that the independence, the data of any particular subject are independent of the data of all other subjects. And also, we need to check the normality of the data using, SPSS. You can check the normality of the data. In the population, the data on the dependent variable are normally distributed for each of the possible combinations of the level of X variables. If the data is normally distributed, then we can go for multiple linear regression analysis. Each of the variables should be normally distributed. That's the basic criteria of executing multiple linear regression analysis. And when the next one is a homogeneity in the population, the variance of the dependent variable for each of the possible combination of the levels of X variables are equal. And the next, assumption is that, basic assumption is that the variables should be linearly interrelated. I mean that in the population, the relation between the dependent variable and the independent variable is linear when all other independent variables are held constant. So I think when we are trying to use multiple linear regression model, this data has to abide by this basic assumption. We need to check on that. And when you talk about the differences between a simple versus multiple regression analysis, it is quite obvious fact that in simple regression analysis we have only one dependent variable and predicted from one independent variable. I need to stress on that, one independent variable, because in simple regression analysis we are using only one dependent variable and one independent variable. Whereas in multiple regression analysis we are using one dependent variable, but it has been predicted by multiple independent variable like x1, x2, and etc. Do you understand this? And the next one is, let's talk about the, here we get only one regression coefficient, but here for each independent variable, we will get each regression coefficient value associated with that specific independent variable. And next one is here R square. When you talk about R square, the proportion of variance in dependent variable Y predictable from X, whereas in multiple regression analysis, the proportion of variance in dependent variable Y predictable by set of independent variables. So that is very, very important as far as the multiple regression is concerned. So hope with these features, we can distinguish the differences between simple and multiple regression analysis. Next one is, let us move further to understand the equation aspects of multiple linear regression equation. So I can show you here, this is called the dependent variable, this is a constant factor, and this one is independent variable, and the next independent variable, and just like that it is followed on. So Y is the dependent variable and X is the independent predicted variable, and this dependent variable is predicted by the independent variable. The respective coefficient value will determine how much the dependent variable has been predicted by this each independent variable, and A is nothing but the raw score equation, which includes a constant or Y. It means that intercept OB Y axis representing the value of Y when X is equal to 0. So B is equal to weight or partial regression coefficient, and X1 is considered to be the independent variable. The BS shows the relative contribution of the independent variable on the dependent variable when controlling for the effects of the other predicted. Regression linear model building. So what happens here? Each predictor is taken in turn, that is, all other predictors are first placed in the equation, and then the predictor of the interest is entered. This allows us to determine the unique contributions. So this allows us to determine the unique contribution of the predictor variable. By repeating the procedure for each predictor, we can determine the unique contribution of each independent variable. This thus it facilitates the model building exercise using these variables on the dependent variable. Next one, different ways of building regression models. So one is, there are many models. I think enter method or simultaneous method, all independent variables entered together, that we call it as enter method, and stepwise method, our independent variables entered according to some order. So in SPSS, is automatically it has been put in order by size or correlation with the independent variable in order of significance. And also we have a hierarchical independent variable entered in stages. So these are the three methods, but we are going to talk about the simultaneous method. We call it as enter method, since all independent variables are entered simultaneously into the talk about this. Let's move on to using this one. So if you open up the multiple regression analysis using the SPSS, you need to go to analyze, and you have to from analyze you need to go to regression, and regression to linear. So once you move it, then what happens, you get a box like this. You put that dependent variable, whatever the dependent variable, you try to put it here. And the next one is you try to put this independent variable over here, and just it is by default we have enter method here, and don't press any other statistics, and everything is okay. Just hit the OK button. So what happen, if you press the statistics, you will have an open up box like this. By default it will be here. So just give you continue, because use probability of F 0.0 already default. By default it is given 0.05, and include constant in equation, so that is always there. Click. So by default exclude cases listwise, continue button. Then what happen, you get an output like this. So this is called R and R square and adjusted R square. So when you run regression analysis on SPSS, you get three tables. Each tells you something about relationship. The first is the model summary. The R is the Pearson product movement correlation coefficient. In this case, R is 0.736. R is the square root of R squared and is the correlation between observed and predicted values of the dependent variable, which I was explaining you. And next one is when you talk about the R, talk about the model fit, and it's okay. 0.736, it's okay. And R square talks about the relationship between the dependent variable and independent variable. And the error where R square is the proportion of variance in the dependent variable, in this case income per capita, which can be predicted from independent variable level of education. The value indicate that 54.2% of the variance in income can be predicted from the variable education. So this is with the simple linear regression. R square is also called the coefficient of determination. So we have to, this R square value is very important in writing inferences using multiple regression analysis. And next one is we talk about adjusted R square. The adjusted R square attempt to yield a more honest value to estimate R squared for the population. The value of R square was 0.542, while the value of adjusted R square is 0.532. There is not much difference because we are dealing with only one variable. And the number of observation, the independent variable, is small and the number of predictors is large. In that case, I think there will be much greater difference between R square and adjusted R square. Next one is the second table we receive out of SPSS analysis is called this ANOVA table. If the p-value is greater than 0.05, it means that you would say that the group of independent variables does not statistically significant relationship with the dependent variable. But in this case, it is lesser than 0.05, and we can conclude that yes, there is a statistical relationship between independent variable and dependent variable, so that the group of independent variable does not reliably predict the dependent variable in this case. Next one is the regression coefficient. You can look at the regression coefficient. So you can have this beta value, okay, and it is it is called the standardized coefficient value, beta. These are the coefficients that you would obtain if you standardize all the variables in the regression, including the dependent and all of the independent variable, and you can run the regression test. So if you run that, what happens, you can see that how much 73.6% it is having a relationship, it is having a variance with that of the dependent variable. So by standardizing the variable before running the regression, you have to put all of the variables on the same scale, and you can compare the magnitude of the coefficient to see which one has more of an effect on the dependent variable. So this is a very good statistical tool whereby we can really predict the value of each independent variable and how much it is so significant or important as far as in predicting the dependent variable. So in many business contexts, I think we can run this multiple regression analysis to predict the latent dependent variable. So you will also notice that larger betas are associated with the larger t values. That's the thing. So you can see that it is so significant, so we have a larger t value. So next one is the SPSS output. I already showed you. This is the first table, second table, and And if you have a multiple variable like this, you go to this significant table, and you can see this only this particular variable is significant. So here weight of the dependent variables is days in the hospital, in case of our discussion of Vignet Hospital, and the weight of the subject is very, very important, and this is very, very significant when you go for this treatment of the patient. So weight of the subject, this is significant. Why it is significant? Because of the fact that this value is lesser than 0.05, and if you look and notice that the t value is also looking to be very high, that is 2.357. So that's where, if any of the variable is significant, no, I don't think no value is observed to be lesser than 0.05. So we cannot, infer that that any of the significant variables other than weight of the subject is available in this table. So with that, I think to recap, we start with multiple regression analysis. Then we start with factor analysis, and then we also demonstrated using SPSS, and also we start with the fundamental understanding of multiple regression analysis and simple regression analysis, and which context we will be using this simple and multiple regression analysis, and hope these two multivariate technique will be very, very useful for you in your business research process. Wherever there is a practical situation demands, you can employ these two techniques to understand which are the independent variable is trying to predict the dependent variable, and you can also reduce the number of variables into minimum using exploratory factor analysis. I mean, you can reduce into minimum factors, okay, using factor analysis, and you can build a theory using these two multivariate technique. Hope you guys have understood clearly and get fundamental clarity on these two statistical technique. One is factor analysis, we call it as EFA, exploratory factor analysis, and the next one is multiple linear regression analysis. Hope you guys enjoyed the session. Thank you so much.